Hey everyone, Gene here. Today we're diving deep into the world of Java multithreading. We'll explore two essential concepts, thread-local data and timers. These tools are incredibly powerful for managing thread-specific data and scheduling tasks for future execution. If you're new to this series, be sure to check out the previous video where we explored the functionality of wait and notify within Java multithreading. This topic complements today's lesson and will deepen your knowledge of Java multithreading. First up, let's talk about thread-local data. Imagine you have a multi-threaded application where each thread needs its own unique data. Thread-local data provides a way to associate data with each thread, ensuring isolation and preventing interference. Or imagine a scenario where you have multiple threads accessing shared variables. If you're not careful, you could run into concurrency issues. Thread-local data offers a solution by giving each thread its own private copy of variables. To demonstrate, we'll create a simple example where each thread has its own unique identifier. Let's take a look at the code. Alright, let's start with a code example. Let's create a new class, thread-local example, implementing the runnable. And in here, let's create a new private static volatile variable of type thread-local, taking strings, which we call user ID. Now let's override the run method. And inside the run method, we define ourselves a new runnable in which we override the run method. Now let's first define what we want to do in here. First we want to get the thread name, then we want to set the thread local variable, and then we want to print the values. Let's first get the thread name. This can easily be done by calling thread get current thread get name, which we save in a string variable name. Now let's go to the next point, setting the thread local value. Here we build ourselves a switch which checks the name. If the name is A, we set the user ID to alpha. If it's B, we set the user ID to beta. And if it's not set at all, we set it to nullus. Alright, let's print the values. For that, we're going to make use of the printf method. First, we print the thread name, and then we print the thread local value, which we get from the name variable and the user ID.get method. Alright, now let's define ourselves three threads, in which we all pass the runnable. Then we set the name for thread T1 to A, and for the thread T2 we set it to B, and for thread T3 we don't set it at all. Now let's start all three threads. Alright, let's go back to the main method and create a new instance of the thread local example class that we just created and run it. Now let's run the application. And here we can see the naming. Even though we use the same variable, every thread enjoys to have its own context, meaning that thread B has the value beta, the thread that we didn't give a name to has the value nullus, and the thread named A has the value alpha. Now let's discuss Inheritable Thread-Local. This class extends the functionality of thread-local by allowing data to be inherited from parent to child threads. This is particularly useful in scenarios where you want to propagate data across thread generations. Think about a logging framework where you want to track the thread's origin. Inheritable Thread-Local can help you achieve this by passing information from the initial thread down to its descendants. Let's see how this works in practice with a parent thread and a child thread, where the child thread uses info that was set in a parent thread. Alright, now let's take a look at the Inheritable Thread-Local example. For that, we're going to create a new class, Inheritable Thread-Local example, implementing the runnable. And here we start right away by creating a private static final inheritable thread local variable that we call initval and which takes an integer. Alright, let's override the run method. In here we start by creating a new runnable, which we call parent. And within this runnable, we start by setting the int val of the inheritable thread local to 42. And yes, 42 is the most important number of the universe. And I believe that many of you already know that. Alright, let's get back to the example. So we're going to create another runnable. This time we call it child. And in here we start by getting the thread name using thread current thread get name. And we save it in a string variable name. Now we are ready to print the child values by making use of the printf method. And we output thread name and inheritable thread local value. The thread name we get it from the name variable. And the inheritable thread local value, we get it from the intval.get method. Alright, now let's leave the child context and go back to the parent context. Here we just repeat what we just did. We get first the thread name, thread current thread get name, which we save in the string variable name. And then we create the exact same output, but this time for the parent. First the thread name, and then the inheritable thread local value. Alright, now let's create the child thread. First by creating a new thread, which we call child thread, and in which we pass the runnable child. Then we give the child thread a name, which we call child, and then we start the child thread. Now let's go out of this context and go back to the run methods context and do the exact same thing, but this time for the parent thread. So thread, parent thread, and then a new instance of thread, and the parameter is the parent runnable. Then we set the name to parent and we start the thread. Alright, let's go back to the main method and create a new instance of Inheritable Thread-Local example and run it. And here we can see the output. First we have the parent thread with the Inheritable Thread-Local value of 42. And then we have the child thread also having the Inheritable Thread-Local value of 42, which was set in a parent and not in a child. Next, let's explore timers, a powerful tool for scheduling tasks to be executed at specific times or intervals. Timers are particularly useful for tasks like background processing, periodic updates, or delayed actions. Imagine you want to schedule a task to run every 5 seconds, or you need to send a delayed notification. Timers provide a flexible way to achieve these goals. We'll look at two primary types of timers: one-shot timers, which execute a task once, and interval timers, which execute a task repeatedly at fixed intervals. To use timers, we'll create a timer task class that defines the task to be executed. Then we'll use a timer object to schedule the task. Let's see some code examples to illustrate this. Alright, now let's take a look at the timer one-shot example. For that, we're going to create a new class, timer one-shot example, implementing the runnable. And here right away, we're going to override the run method and start by creating a new timer. And right after that, we also create a new timer task, in which we also override the run method, in which we just make use of the printf method, which outputs one-shot task at, well, a certain time. Let's create a new method for that. Private string current time. So let's first get the time using local datetime and now, and then convert that to a local time. And this time we convert it to string and return it to the caller, which is the printf method. Alright, now let's also cancel the timer, which we have to do after having done the job. And now outside of the context of the timer task, we again make use of the printf method to output the time when we started timing the one-shot task. And then the very last thing that we need to do is create a schedule for that, in which we pass the task that we want to execute and the delay, which we set to 1000 milliseconds. Alright, let's go back to the main method and create a new instance of timer one-shot example and run the application. And here you can see first we have timing one-shot as an output, and 1 second later we have the one-shot task. Alright, now let's take a look at the timer interval example. For that we're going to copy the class that we just created before the timer one-shot example and change a couple of values, because all in all the class is very similar to the other one. Alright, let's change the name, timer interval example, and then around the timer.cancel we put an if condition which cancels the task as soon as the counter reaches 5. And in every other case, the counter is incremented by 1. Now let's go down to the timer schedule, in which we add a 0 in the middle, meaning that we have no delay. And the period, that's the interval, we set it to 2000 milliseconds, meaning that the task will run every 2000 milliseconds. Now let's also change the output from one-shot to interval. And now let's go back to the main method and create a new instance of the timer interval example class and run the application. And here you can see that we started timing the interval. Right after that we executed our first iteration. And then every 2 seconds we have one interval, until the 5th interval is reached, which is the last one. By mastering thread-local data and timers, you can write more efficient, reliable, and maintainable multi-threaded applications. If you found this video helpful, please give it a like and subscribe to stay tuned to the latest Java programming tutorials. In the next video, we'll dive into the world of executors, futures, and thread pools, so stay tuned for that. Thanks for watching and happy coding!